Assalamualaikum warahmatullahi wabarakatuh. Today we will be presenting our group mini project entitled Automatic Plant Watering System using IoT for the future of agriculture. We are from class 8F5 and our group consists of 3 members, which are Jasir bin Sulaiman as our group leader, next Muhammad Saifullah bin Muhammad Sabri, and lastly me myself Muhammad Al-Fatul Muslim bin Azman. First we go to introduction. The self-sustaining plant watering system is an automated system that effectively maintains the moisture level of plants without consistent human intervention based on Internet of Things (IoT) technology. With the increasing demand of indoor and outdoor gardening, there is a need of innovative approach to ensure optimal plant care. This project aims to design and implement the system that utilize sensor technologies, irrigation technique, and automation system to monitor soil moisture, deliver water when necessary, and conserve water resource. By creating a sustainable and user-friendly solution, the project aims to promote plant health and reduce the effort required for plant watering. Make it an ideal choice for both gardening enthusiasts and those with limited time for plant care. Next, problem statement. The issue is water scarcity poses a significant challenge in the agricultural industry, since both over-irrigation and under-irrigation can lead to reduced crop yields, wastewater resource, and increased expense for farmers. Manual monitoring and watering of plants are labor-intensive and prone to human error, making the process insufficient and time-consuming. As for the solution, an automated system has been developed by engineers which is capable of accurately detecting soil moisture level and providing appropriate irrigation. Implementing such a system will improve water efficiency and promote healthier crop growth. There are 3 main objectives on doing this project. First, design and implement an automated system that efficiently monitor and maintain the moisture level of plants. Second, allowing users to customize watering schedule and receive notification about plant irrigation and system condition status. And lastly, low maintenance solution that promote plant well-being and reduce water waste. Now we move to literature review. First, research and finding. Research has found on sensor technologies for accurate soil moisture measurement, irrigation technique for efficient water delivery, and automation system for intelligent control. Automation system based on microcontroller such as Arduino or Raspberry Pi has been utilized to collect sensor data and control irrigation schedule. Next, specific area of interest. Within the self-sustaining plant watering system domain, this literature review focuses on the irrigation of machine learning and data analysis technique by leveraging historical data, weather pattern, and plant-specific requirements. Machine learning algorithm has been employed to optimize watering schedule dynamically. And lastly, the current ideas. Recent research suggests that the integration of machine learning algorithm can enhance the efficiency and intelligence of self-sustaining plant watering system. By incorporating real-time weathering data and plant-specific characteristics, this system can adapt weather schedule to changing environmental conditions and individual plant needs.
Assalamualaikum warahmatullahi wabarakatuh. I will be presenting the methodology of our project. For our project, we need 4 components, which is soil moisture sensor. For the watering mechanism, we need the submersible pump, microcontroller unit, and the last one is relay module. For the soil moisture sensor, we will put it near the plant's roots, and it will collect the real-time data to collect the moisture content near the plants. For the microcontroller unit, we will use the EP8266. This microcontroller unit is used to collect the data from the sensors and make a decision based on the data threshold, predefined moisture threshold. For the watering mechanism, it will be designed to deliver water to the plant's root when it is needed. It was determined based on the microcontroller unit. When the moisture is low, the pump will be turned on, and when the moisture is high, the pump will be turned off. Okay, for the last component, which is the relay module, the microcontroller unit will open the relay module when the moisture sensor detects the moisture below the required level, and this relay module will cut off the water supply when the moisture was attained at the desired level.
Right now, I will show you the functionality of our product.
This is a quick video on how our automatic watering plant system works. As you can see here, the system is just about to start and you can see the LCD display the moisture level. Right now, the Blink app shows that the moisture level is at 0 and the button to activate the water pump is turned off. And this is the plant condition. When I turn on the mini water pump using the Blink app, you can see here that the water come out of the pipe. And then now you can see that the moisture level is slowly rising. When I turn off the water pump, the moisture level stops rising and you can see the LCD shows motor is turned off. And here you can see the water stop coming out of the pipe.
Okay, next is the program flowchart. The Node MCU ESP8266 board initialization and the creation of a Wi-Fi connection are shown first in the flowchart. This makes it possible for the board and your phone's Blink app to connect. The next step is to attach the soil moisture sensor to the circuit board and configure it to read the soil's moisture content. This information is used to decide whether the plant needs watering. The flowchart advances to a decision step after obtaining the moisture level and determines if it is below a predetermined threshold. Using this threshold, you may decide if the plant needs watering or not. The program advances to subsequent stages if the moisture level is below the threshold. Otherwise, it returns to reading the moisture level. The tiny water jump is turned on next, and a timer is programmed to operate it for a particular amount of time to make sure the plant gets enough water. The LCD shows the user their current watering status and gives them visual feedback. The flowchart has been updated with new stages because of the integration of the Blink app. The program updates the Blink app with the watering status and sensor data after showing the watering status on the user's mobile device. This acts as an output by giving them real-time information. The flowchart also has a decision point to look for instructions or modifications from the Blink app that will need control. The program moves on with making any changes if any commands such as modifying the threshold or watering time are received. By utilizing the Blink app to operate and monitor the plant watering system remotely, two-way communication is made possible. A waiting interval is also included in the flowchart to allow for the completion of the watering duration. Relay module deactivation turns off the tiny water pump when the time expires. The flowchart repeats the moisture level information so that the system may monitor and water more plants as needed. It keeps on till the user chooses to stop the program. Okay, so now you can see the whole coding for automatic plant watering system. I will break down the code into 5 sections so that you have a better understanding of it. So for the first section, this section includes the necessary libraries, define the LCD display object, and declares variable for Blink authentication, Wi-Fi credentials, and a timer object. Next section. Before going into void setup, I define the pin assignments for the soil moisture sensor to A0 and water pump to D3. In the setup function, as you can see in the slide, the water pump pin, LCD display and Blink is initialized. The water pump has been set as an output and the Blink is initialized with provided authentication, Wi-Fi SSID, the username and the password. At the call function, the LCD display's timer is set to call the soil moisture sensor, which will function every 100 milliseconds. For the third section, as you can see the Blink write V1 coding, the function is a Blink callback that handles the state of a virtual button V1 on the Blink app. When the user presses the button on the Blink app, the relay variable is updated accordingly. If relay is set to 1, the water pump is turned on and the LCD display's motor is on. Otherwise, the water pump is turned off and the LCD display's motor is off. For the next section, the soil moisture sensor function reads the analog value from the soil moisture sensor connected to pin A0, which has been set earlier. The sensor value is mapped to a range of 0 to 100 and then inverted to represent the moisture level. The moisture value then is sent to a blink virtual pin V0 using blink virtual write function. As you can see at the slide, okay, at the LCD.print, the LCD display show moisture followed by the moisture value. For the last section, the loop function continuously runs blink and the timer to maintain the connection and execute the necessary functions. That's all for the coding.
Next, I'll be highlighting four main outcomes from our project. First of all, our project will promote water efficiency and conservation. How? By accurately detecting soil moisture levels and providing irrigation only when necessary. The system ensures optimal water usage by minimizing over-irrigation. The second one is our project enhance crop health and yield. How? By maintaining appropriate soil moisture levels, which is crucial for healthy plant growth and high crop yields. The automatic plant watering system powered by moisture sensors ensures that plants receive adequate irrigation precisely when needed. The third one is labor and time savings. Our project will be automating the plant watering process, and our project reduce the need for manual intervention. The system continuously monitors soil moisture levels and delivers irrigation automatically. The last one, which is integration of robotics, automation, and IoT. Our project aligns with the robotics and automation cost outcomes by integrating key concepts from these fields. It combines the use of robotics and automation principles to design an automatic plant watering system. The system of our project incorporates our IoT technology to connect sensors, microcontrollers, and water supply mechanism, enabling remote monitoring and control. So, for the conclusion of our project, this autonomous plant watering system were based on the Internet of Things technology. It is an innovative solution to the problem of water management in agriculture. The technology improves irrigation efficiency, reduce water waste, and boosts crop quality by combining soil moisture sensor, microcontroller units, and the Internet of Things connection. Applying automation concepts, including IoT technology, cultivating practical problem skills, and addressing ethical issues are always in which this project ties with the cost result of the robotics and automation, MEM 665. This project will learn not only valuable technical skills, but also receive insight into how robots and automations might revolutionize the agriculture sector. And that's all from us. Thank you.